place it anywhere you want. Okay, so what you can do is you can just lift the vector from a place and reposition it wherever you want. Okay, so in this case, I have just repositioned both the vectors, and I can see that if I'm able to close this particular parallelogram like this, okay, that is drawing perpendicular vectors to B and A. Okay, they may not be always perpendicular. It's just I'm just closing this loop. So the vector from the initial start point towards this end point will be the resultant. Okay, so A plus B will be equal to vector, will be equal to vector R. Okay, this is something you might have already learned, isn't it?
Yeah.
I'm just revising it. What happens in triangle law? Okay, this was parallelogram law. What happens in triangle law is you just take vector here, take a vector here, and the resultant is nothing but this. Okay, so this is the basic difference in the, this is the parallelogram law, and this is the triangle law. Okay, now let's see how you deal with the subtraction. Okay, okay, so what's happening here is, again, you have A. Okay, the same case we'll take, but here you actually draw it on the opposite side. Why? Because you are trying to subtract it, isn't it? So
Yeah.
what you'll get here, once you try to use the parallelogram law, see, the law of parallelograms will actually tell you that this line should be parallel to this line and equal, and this line should be parallel and equal to this line, isn't it?
Mhm.
So in that way, if you draw, you'll find a resultant which is pointing here. In the first case, you can see that the resultant here, addition case, the resultant is slightly larger than A and B because it got added, isn't it? And
Mhm.
here, the resultant got shortened. Why? Because we have subtracted it. Isn't that logical?
Yeah.
Okay. So now going further, here also you can actually apply the triangle rule. How? You can actually put A here, then you can actually put B here, and you'll see that the R has resulted in the same way. It doesn't matter whether you can use the rule of parallelograms or use the triangle rule, you'll get the same answer. Okay. Now, how you have a magnitude addition? This is the direction sense. So the magnitude area, suppose you have this alpha angle, you have this theta angle, okay, and you have a theta. Okay. So what you can do is uh, the forces of resultant magnitude is equals to F, I'll call it FA, okay, acting along A plus the square FB square minus AB cos of beta. Okay, fine.
Yeah.
So beta is the angle. Be very careful. You have to take an angle which is actually between the forces. Okay, I'm purposefully actually writing this to tell you that it is between the forces. Okay, now
Between A and B or
correct.
between okay.
No, it should be one second. Mhm. Yeah, so it should be between A and B. I think the diagram we have to put slightly modify. Yeah, it should be between A and B. Okay, between A and B. Okay,
Yeah.
in this case, it will be here. Okay,
Mhm.
fine. So, oh, fine. So even if the notations are different, don't worry. You have to remember that the angle has to be between the forces. Okay, that's why this statement I have written very clearly. Okay, notations may be different in different textbooks. Okay, so this law is basically known as the cosine law. Fine. Now, what is the sine law? Okay, so in any triangle, you can actually, whether it is addition or subtraction, okay, you can actually find that the cos of the angle, okay, or the other way, the cos of the angle upon the force that is opposite to it have the same ratios. Okay, okay, so this is a very important property that we can use while solving the equation. Okay, so you have a cosine law where you have in the under root the squared forces of, addition of square of the forces minus 2ab. Basically, this is FA and FB. Sorry for the notation change. Okay, I think now it's clear, right?
Yeah.
So under root of FS square plus FB square minus 2 FAFB cos beta. It can be beta, theta, whatever. It should be the angle between the forces. Okay, and the sine law. Okay, which tells us the ratio of the angle and the force opposite to it. Okay, so alpha has the opposite of B force, so FB
Mhm.
here. Okay, so and theta has opposite A. That's why it's theta and FA. And same way beta has resultant, isn't it?
Yeah.
So I hope I'm clear till here.
Yeah, it's clear.
Okay. So now let's see example. Okay. Okay. So we have a point. This is the axis. Okay. And we have a force F1, which is have the magnitude of 100 newtons. It is acting at a angle of 15 degrees from the horizontal axis.
Mhm.
Okay. At the same time, from the vertical axis, you have another force, which is F2. Okay. And it has a magnitude of 150 newtons. Okay. It is at a degree of 10 degrees from here.
Mhm.
Okay. So how are you gonna add this? Okay. See, be very careful. You have to apply the cosine law, and there's a negative sign, and the angle is between the forces. And I have considered the triangle. Okay, so always remember that with respect to this triangle only we have considered. If we
Mhm.
had to add this, okay, see, this case is for subtraction. If you had to add this, then what would have happened? A would have been like this, and B would have been like this. Okay, the same way. And then the resultant would have been like this, isn't it?
Yeah.
So be very careful whether you're adding or subtracting. Okay. So what happens basically, I'll tell you. When you subtract it, the angle will be a smaller angle, and this negative sign will take care of this part being subtracted from the total squared addition, isn't it?
Mhm.
This total thing gets subtracted. I hope you understand.
Yeah.
It's have a negative sign. But at the
Mhm.
same way, when you have a addition and this angle becomes greater than 90, the cosine of that angle, which is between here, will be again a negative value, which will nullify this particular negative and becomes positive. So what happens is the total component, this 2FAFB cos beta, becomes a addition to this earlier two things. Okay, it works that way. We'll just see in this particular problem. Okay, so what we're going to do here. So there is an x-axis, y-axis. Okay, so we're gonna use the triangle law. Okay, cosine law. So I put F1 here. Just a second. I put F1 here. Okay, then I put F2 here. Okay, so here, what is the angle? It is 15 degrees. What would be the angle here with respect to the horizontal? Can you tell me? If it's 10 degree with the vertical, it should be how much with the horizontal? The total degrees you have, sorry,
80.
should be 80, right? Because the total degrees you have is only 90, isn't it, between x and y? So if you cut away 10 from one side, the other side it's only 80, isn't it? Am I clear? Hello? I think it's not audible. Hello?
I can hear you. I don't know if you can hear me.
Yeah, it was not audible. So I was clear with this 80, right?
Yeah.
So
Yeah.
that is how you find. Yeah. Now, you put both the forces in a triangle form, and since you're adding it, the sense is, taken this way, and now you have a resultant here. Okay. So what angle do we have between this? We're going to need this angle. Okay. Let it be beta angle. We're going to need this angle. Can you tell me what is this angle? Very easy way to find out. Just extend this particular horizontal line and try to see
You could
when
do
you have a whole
360 degrees minus, no, 360 plus 15. Or no, 180 plus 15, sorry. Right.
Yeah. So what we're gonna do is we're gonna see that these are two parallel lines, isn't it? First of
Yeah.
all, these are two parallel lines, horizontal. So when you where you have a line cutting two parallel line like this, these are the two parallel lines, and this particular F1 is cutting this. So this 15 degrees and this 15 degrees are same, isn't it?
Yeah.
So this is the first thing. So this small, you get a, here this angle you get is 15. Okay. What about the bigger angle? The bigger angle, you can simply use the property of, this is 80. Okay. So this remaining, since this is horizontal, this remaining should be, 180 degree minus 80, that is 100. Isn't it?
Yeah.
Are you able to follow?
Yeah.
What happens here is now beta becomes 100 plus 15 degrees, that is 115 degrees. Okay. Now you try to add them. So let's go ahead. F1 square plus F2 squared minus 2 F1 F2 cos of the angle between them. Okay. I told you that.
Plus,
Sorry.
wouldn't it be plus, like you said?
No, it won't be, because now we are yet to put the angles here. Once you put this angle here, the cos will take care of the sine.
Yeah.
The sign, the negative or positive, will be handled by the cos. You don't worry about it. Okay. Can you tell me what is cos 115 degrees? Then you'll just get to know what I was talking about. Square plus 1 square. Then it's 200 into
Negative 0.
negative. Yeah. I'll just put it in the calculator.
Negative
Uh,
0.42.
115. 0.325, right?
Um,
Isn't it?
yeah.
No, 1 second. You should be
I
putting
think
in
it's
degrees.
0.422 when I put it on, yeah, because that would be
You
like,
should be putting in degrees. So it's 0.422. You're correct. It's not radians, it's degrees.
yeah.
So be careful. 422. Okay. 4. Okay. So see the negative sign here and here cancels out. You
Mm,
understand?
yeah.
So the cos will take care. You have to put a negative and to go ahead. When the angle is found, it will take care on its own. So can you do a quick calculation? Or just to save time, I'll put it here. It's 230 newtons.
Mhm.
Okay. The resultant.
Could you also
Four.
solve this like using components? Like you can like divide it into like X and Y.
Yeah, you want me to divide it into fx and fy, isn't it?
Saying like that's also possible, right? Like it would be,
Sorry, I didn't get you.
it's also a possible option, right? Like it's
Yeah.
simpler.
That is going to come. This was the first way how you resolve.
Yeah.
The next problem which I'm going to take is coplanar forces, and how do you resolve into the x component and y component that is coming on.
Yeah.
I hope it's clear till here.
Yeah, it's clear.
Can I know which university you're from, like just to get
Um,
hold of a textbook?
it's Toronto Metropolitan. I sent you the textbook that we
Oh,
use.
is it? Oh, it will be with my team. I'll just get it from them.
Mm.
Anyways, do you want me to take one more problem, as you said, about
Sure.
the x and y? Okay. I hope this is clear at least, right?
Yeah, that is clear.
Okay. Now let us talk about the coplanar forces. Okay. The coplanar forces. There's no A here, so there is a coplanar forces. What is coplanar forces? Uh, See, if there are forces which are lying in the xy plane, okay. So this is there is a F which is lying here, which is in the xy plane. So you can resolve this, this angle. You can resolve this forces into its component of say x or component of y. Different textbooks will give you different axis notation here. Okay. So based on the problem, we can just change the axis, but the concept doesn't change. Okay. So what happens when you resolve? So fx is going along the x-axis and fy is going along the y-axis. What is happening here is this angle becomes theta. Okay. And if you see this particular triangle, okay, I told you you can move the forces where and when you want. Okay. So this fellow here is fx and this fellow here is fy.
Yeah.
Okay. Zooming in, I'll tell you that this theta over here, okay, will help you to get fx. How?
You can do F cos theta for
Well,
FX.
so if you take f cos of theta, it is nothing but fx. And if you take f sine of theta, it's nothing but fy. If you get confused, if there are too many angles given, always remember that the fx or the cosine will be always the nearest to the theta.
Yeah.
Whichever is nearest to the theta will always take the cosine. Okay. Which is always the opposite to theta will take the sine.
Mhm.
I hope you can remember that. Okay.
Yeah.
So that is how it is. Also, there is another way to express it. You call it the Cartesian coordinate. Sometimes the problem is given in Cartesian coordinates.
Like IJ,
What you do?
that
Sorry.
thing. Is it like the IJK? Like
Correct.
you.
It's just for expression purpose. You don't need to have confusion. So what happens is you have a x and y plane, and you have I. Usually, people express it as I hat or something. So it doesn't matter. It's a vector. It's a unit vector. Okay. It's a unit vector along the x-axis. Same way, J is nothing but a unit vector along y-axis, and K is nothing but here K doesn't exist here because we are talking about only xy plane. But anyways, I'm just writing it down. So what happens is when you resolve the forces, okay, into fx and fy, whatever, these are actually acting along the unit vector. Okay, acting along the unit vectors. So here you get the magnitude, isn't it?
Yeah.
So what I'm gonna do is I'm gonna write f bar. That is the vector form of it. Okay. Here it was a pure magnitude. It was not talking about the direction. But here when I write f bar, I have to be careful about the direction as well. So what is f bar? F bar is nothing but the x component into I plus the y component into j. Why I'm writing it so far? Because whatever x component you have, whether you have n number of forces, like you have f1, f2, f3, f4, so you'll have f1x, f1, f2x, f3x, f4x. So no matter how many forces you have, all the x component can go and sit here. Okay. And similarly, all the y components can go and sit here. Okay. And the j remains outside. So that means so many forces are acting in the x direction and so many forces in the y direction. And this gives you the total force vector. Okay.
Yeah.
So like I told you, for example, we'll stop with line. Okay. So you have, for example, F1. Okay. You have F2. Okay. So this will have a x component and y component. This will have a x component and a y component, isn't it? So
Yeah.
what I was talking about is f1x plus f2x, it will be
Mhm.
I. Then again, f1y plus f2y will be j. Okay. So f bar will be expressed as this one plus this one. Okay. This is the total vector. Okay. And if you have a f3 file which is going the other way, what do we do? This is
You
fx,
subtract
f3x, f3y. Okay. So what do we do here? We simply, the x is going in the opposite direction, isn't it?
Mhm.
So you have a negative here. Yes or no?
Yeah.
And you add f3y because it's on the positive sense.
Yeah.
Okay. That is as simple as it. Okay. So this is how it works. Okay. So this was a theory part. Let's take a problem over it. Okay, no, it's not over. A small thing. Uh, so you have all the x's. So you have all the summation of x, that is f1x, f2x, okay, whatever. And you have a summation of fy, okay,
Mhm.
sorry, f1, f1y, and f2y, or whatever. It can be positive, negative, whatever. So you have the collection of all these forces. Okay. So what you're going to do is the resultant. We didn't find the resultant here. So resultant will be what? It will be
Fx
having a
squared.
magnitude of the summation of fx squared plus summation of
F.
fy squared. This is the magnitude. Okay. And since there are so many forces, you cannot apply the triangle and parallelogram law. So what you're going to do is you're going to take a tangent of theta. Okay. Okay. So what is theta here? Theta will
Yeah.
be the angle between the x and the y component. So I'll just draw it down. Okay. So Suppose this is the resultant vector. Okay, it makes the angle of theta here. Okay, so with the x-axis, it is the angle. So summation of all the fx is here, and summation of all fy is here. Do you agree with this?
Yeah.
So all the forces you have put as a fx and fy, you have a resultant out of it, and you need to find the angle theta. Okay, so it will result in like this. This triangle will be like this. This will be like this. So now this is fr. This is summation of fy, summation of fx. Okay. So what do we do?
You do
Just a
Fy
second.
Fx.
Yeah. So you don't have a resultant here. So you can take a ratio of the opposite upon the
Adjacent.
adjacent. That is summation of fy upon summation of fx. Okay. This gives you the angle between the x and the resultant. Okay.
Yeah.
You can compute it as theta is equals to tan inverse of I hope it's clear now.
Clear.
Yeah. I hope it's clear.
It's clear.
Okay. We'll take a small example today so that okay. Cool. So what does the example say? Says that there's a hinge point here on the axis at the origin where you have a force of 600 newtons. Okay. Inclined at 30 degrees from the x. And there is another force which is with respect to the vertical, which is at 45 degrees and magnitude of 400 newtons. Okay. So what you got to do is you have to find the resultant as well as you have to find the find resultant and the direction. Basically the magnitude and the direction. Okay. So there are two ways to approach the problem. So I'll tell you the first way first, how to approach. Now you know it better that we have to resolve it in forces. Okay. We have to put the summation of fx is equals to what? Okay. So it would be nothing but this force x and then subtraction of this force x, isn't it? So it will be do you agree?
Yeah.
So you get nothing but I just write it down for you to save time. Okay. You people can use calculator in your university, right?
Yes.
So it will be easy. So you get a direct summation of fx and fy. Okay. And the same way for fy, it will be this direction and addition of this direction. Nothing but 600 sine of 30 plus 400 sine of 45. Okay, the addition. So you get, I think it's 582.8 newtons. Okay. So sometimes people write the notation as well, that it is upwards or it's right. Okay. So what is the resultant force? The resultant force is nothing but
Magnitude squared.
the fx fy. This is the
Yeah.
same cosine formula if you see, but the cosine of 90 has become 0. Okay.
Mm,
That's why you don't get the cosine part here.
yeah.
I hope you follow it.
Mhm,
There's a cosine part here, but
mhm.
cosine of 90 is nothing but 0. That's why
Yeah.
this formula reduces to only fx and fy.
Mhm.
Okay. That's the beauty. And this can be written as what? Okay. And theta is nothing but equal to
Tan inverse
tan
FY.
inverse of the y upon x.
Mhm.
I is nothing but I 2.8 upon x. Can you tell me what the theta is?
Mhm.
Yeah. Could you do it?
Um, yeah, it should be 67.88 degrees.
Yeah, you're right. So now, since you have found out with a particular method, we'll just write it down for you just to understand in Cartesian as well. So what do we do here? The resultant forces is equals to F1x plus F2x. This is a vector, so F bar. So F1x plus F2x I, okay,
Mhm.
plus F1y plus F2y k. Okay,
J,
now,
right?
sorry, yes. No. So what happens here is you already know the F1x and F2x. Okay, so F1x is nothing but this fellow, and F2x is nothing but this fellow. Okay,
Yeah.
so it's the same thing. This method of writing is different. It's for you to understand. Okay, this
Mhm.
can be positive, and then you can put negative sign here because you are actually having a negative. The direction is changed, isn't it?
Yeah.
Just for you to understand, I'm writing it that way, or you can directly put a negative as well. Okay, I plus. Okay, it goes the J part. Okay, goes to the J part where you write 600 sine of 30 plus. Okay,
Yeah.
so sometimes the problems may be given in this Cartesian system. So you need not panic about it. You have to just extract the x and y components, and you have to
Mhm.
just follow this particular formula, which will actually give you the loads. Okay.
Yeah.
So I hope you followed it till here. We're gonna stop for this class here, and we'll go for the next syllabus in the next class. I hope it was the speed was okay for you.
Yeah, it was okay.
Okay. Any doubts do you have for today?
No.
Okay. So I guess then we'll meet in the next class.